Welcome everyone. Good afternoon. I'm very happy to welcome you to this GÉANT Infoshare on SCION access for universities and research institutes. And I should add to that NRENs, of course, as well. We are going to cover essentially the steps to get access to SCION for all those in the academic environment, especially NRENs, universities and research institutes. So let's get started. Let me see if I can advance the slides. Yes. So for those of you who may not be familiar about SCION, SCION is essentially a next generation internet architecture. And this is just a one-slide summary here. If you're interested in more details about SCION, I have some pointers at the end of this slide deck where you will find further information. So SCION is a next-generation internet architecture that is based on path awareness. It's a path-based network architecture that comes with its peculiarities both in the control plane and in the data plane. In the control plane, essentially, the architecture is dealing with construction and dissemination of so-called path segments. You can see on the right-hand side here in the illustration, different types of path segments that the SCION architecture can include. The blue ones here are so-called up path segments that are segments going from a AS, so all the dots here are ASs, to a so-called core AS. Then we have the orange ones, these are core path segments, and then the green ones, those are down path segments in a remote so-called isolation domain. So the oval circles here are isolation domains. Now, if we have packets that shall be sent from a particular source to a destination, due to the path-aware architecture, they can be sent on multiple paths potentially. And this is what the data plane is dealing with. The data plane essentially combines first different path segments to build an entire end-to-end path. And the packets that are sent on those paths contain the entire information about those end-to-end paths so that intermediate ASs know how to forward those packets. And then the routers that can basically be very simple implementations because they can operate in a stateless manner, simply forward those packets following the information in the header of the packet that includes that end-to-end path. So for example, if there is a packet P1, as shown on the right-hand side, that follows, for example, the path segments from F over C to A, it can do so. And then following the orange core path segments, for example, from A via ASI, J, and M. And then finally, in the down path segment, from ASM through P, and then finally to the destination S. But equally, it's also possible to choose an alternative path, as the packet P2 shows here, that would go from F via D to B, and then from B via K to L, and finally from L via O to S. So these are two totally valid paths that can be individually chosen, and that's also a specialty in SCION by the end host. So the end host decides which paths those packets shall take in order to reach the corresponding destination. Now, this path awareness opens up an entire new set of opportunities for applications. So for example, if you have a file transfer application that is very intense on bandwidth, it can choose a path that is bandwidth optimized. That means it will probably choose segments that provide a lot of network capacity at a certain point. Whereas a voice over IP application, for example, may choose a latency optimized path that potentially doesn't provide as much bandwidth, but is heavily optimized in reducing the latency between the source and the destination. Now, you certainly know about the concept of multi-homing. So already today, many devices are able to do multi-homing, for example, by having both Wi-Fi or LTE connections in place, or a fixed connection, a wired connection, together with a wireless connection. Now, this can be used, that's kind of orthogonal to SCION, but with SCION, there are further benefits, because in the backbone network, you can also choose entirely different paths. And so these two things can be combined, and thereby additional path opportunities to exist in addition to the multi-homing possibility. Now, after this quick introduction into SCION, you may say, well, this seems really hard to deploy, right? There is kind of a chicken and egg problem here. On one hand, you need early adopters that are willing to deploy this architecture. And on the other hand, you need an initial deployment for early adopters to be convinced. And so the only way to achieve that is by providing appropriate incentives to providers, so that they see new opportunities that will generate additional revenue, and or that these new concepts will effectively reduce the operational network costs. Now, there is good news. We have already deployed SCION into production networks, especially in Switzerland. We've seen a lot of adoption recently by ISPs like Swisscom, Sunrise, for example, but also internet exchanges like SwissIX. And I will speak a little bit later about that. Also, the Swiss banking network with SIX and the Swiss National Bank there in the leading position do use SCION as well. Now, what's the reason for these successes? So on one hand, one of the big benefits of SCION is that it's federated and offered thereby as a product by potentially multiple ISPs. Any ISPs can join SCION, like in the public internet, yeah, and benefit from all its properties. Another benefit is that the SCION deployment is entirely overlay free. So rather than building on any weak foundations like an overlay deployment, yeah, that could be problematic, we have a production SCION network already in place that does not rely on BGP at all, and so is entirely overlay free, and is not facing any issues that can potentially arise from the use of BGP, like, for example, link failures, or also attacks, well-known attacks that are run against BGP every day. Now, as I mentioned before, there is one famous example of a production-grade adoption of SCION already in place. That's the Swiss Secure Finance Network, with a number of participants, especially banks in Switzerland, and also insurance companies and security firms. This has been a deployment ongoing since mid last year, yeah, and has really, is really kind of the flagship reference for the SCION production network. Also, Switch, the NREN in Switzerland, has been an early adopter of SCION. Here you can see the flyer that you can also find on the Switch website, basically advertising the SwitchLAN SCION access to universities and research institutes in Switzerland. Now, today I would like to talk about SCION in the European network, GÉANT, and we have already some history here. We started already back in 2018 yeah, talking about SCION deployment in the GÉANT network as well. We had some presentations about SCION in SDF meetings there, and it was then suggested that GTS, which was a service operated by GÉANT back then, the GÉANT testbed service, could be a suitable platform to deploy SCION. And we have done that. We had also a number of research projects together with that, for example, together with the Fed for Fire platform. But it became pretty soon obvious that we need a more stable, perhaps more productive grade deployment, yeah, in order to really achieve these SCION properties that we wanted to demonstrate and that we wanted to have achieved. Just to note, in these early deployments that we had, for example, in context with GTS and Fed for Fire, we had Switch as a node there. We had SCIONLab in the Netherlands, and we had also DFN in Germany, DNREN in Germany, participating in that. Now, this was part of the SCIONLab testbed infrastructure. I will come to that later on again as well. And you can see here the node that GÉANT built in this early deployments as part of the SCIONLab topology. You can see here in gray the different isolation domains existing back then in SCIONLab, with GÉANT basically being a core AS in the EU isolation domain. You see also the Swiss isolation domain here as part of SCIONLab with Switch and Swisscom as core ASs, and then further isolation domains in Asia, as well as North America and in ABS as well. Now, what we have done since these early deployments back in 2020, as some of you may know, the GÉANT testbed service was shut down in September last year. And so it really became a necessity in order to deploy SCION further within the GÉANT infrastructure, especially at the production grade level, to think about what types of opportunities exist to do so. And we sat together with the GÉANT folks, and we had an SEF signed with Switch here in the leading position as NREN, that then became effective in the early 2022. We purchased then servers that were deployed starting in May this year. We had the first two nodes deployed in Geneva. Then later on in July followed two nodes in Paris. And finally, we had also two nodes deployed in Frankfurt. And this is the SCION deployment that we now productively use within GÉANT. So this is just showing how these 6 nodes that I just mentioned are organized in the GÉANT network. So as mentioned, there are 3 GÉANT locations, Geneva, Frankfurt, and Paris, where 2 servers each are running. These servers are connected with each other using 10G links across the GÉANT network. And they also have 10G connectivity to external domains. So basically NRENs, any member of GÉANT can join using a GÉANT Plus link. I will get into that more detailed later on in order to be connected basically with a layer 2 VLAN. We also have these servers equipped with 100G interfaces, so we are prepared essentially to upgrade these nodes as well whenever this connectivity becomes possible. On the SCION level, the topology looks as shown on the right-hand side here. We have basically GÉANT as a SCION AS forming a core node inside the European educational isolation domain. And then any NRANs connecting to that via GÉANT plus layer 2 VLAN essentially becomes a child of that GÉANT SCION parent AS. And then further on, universities that join the NRANs in order to be connected to SCION would then just become children in the topology on the SCION level of those NRANs. Now, after this initial introduction or overview on the current SCION deployment within GÉANT, you may ask yourself, so what can I now do with this deployment as a university or research institute who is interested in SCION, or as an NRAN willing to join this infrastructure? So essentially what this deployment provides you is the possibility to participate in research on those emerging topics that I mentioned in the beginning, path awareness networking, or path awareness or path aware networking, that also enables especially multipath communication. This is something that is definitely not possible on today's single path internet. And I think now is really the window of opportunity where researchers that are willing to join this infrastructure as early participants will have a competitive advantage by being able to leverage this SCION deployment before anyone else. We are prepared to provide these researchers with the necessary tool set. So we have software packages, setup instructions provided for different platforms that enable essentially those researchers to really use SCION natively in different types of applications. And I will mention some applications examples later on. Those software packages essentially have been developed in the scope of our SCIONLab infrastructure. And I want to emphasize the SCIONLab infrastructure is really just an overlay infrastructure, a test environment, and by no means the same type of infrastructure as we are targeting here, where we really want to provide and do provide a productive SCION environment. Now, also, of course, you may ask yourself, okay, what can I do with SCION if I am not into SCION research? And also if there are researchers or users at those universities or research institutes that would like to make use of SCION and benefit from its properties, they can definitely do so. We have an element that is called SCION IP Gateway, short SIG, that essentially enables the use of SCION with any regular IP application. And that then gives room to any users to benefit from those SCION properties, even if they are not involved in SCION research or network research in more broad. And for them, it's essentially no harder than using any regular internet service to use SCION. Now, what are the benefits of getting a SCION connection? So one of the big benefits is the security properties that SCION provides. SCION comes with an authenticated control plane and provides really high resilience against any sort of path hijacks, typical attacks against the BGP, for example. It also provides very high stability. The native multipath capability that comes with a path awareness feature at the network level enables that rapid path failovers can be done that really ensure a very high stability despite occasional path failures in the network. Another big benefit is the control. Thanks to the path awareness, end hosts are able to do path application-specific path control and also optimization. So, for example, if I want my traffic to stay within a certain geographic area, I can do something called geofencing, so I can ensure that my traffic, for example, stays entirely within a certain country, let's say within Germany or within Switzerland or within the European Union. And this is controlled by the sender. So I don't need to trust my provider, but I can really, as a sender, ensure that my packets do take these paths. Moreover, there's also the possibility to do further protection, for example, by using hidden paths. And also there are further mechanisms within SCION that enable it that senders can do path selection in a way that increases their protection against distributed denial of service attacks, for example. And with the multipath capability and the path failover capability or path selection method at the very basic, it's also possible to optimize performance. So SCION application can select essentially the paths that are best for their application, be it based on the latency or the bandwidth, or also other metrics like, for example, packet loss or jitter. I think there is a question. So Martin, if you could quickly read it out to me so that I can potentially answer it either now or at the end of the talk.
Yeah, so the question is, how would you compare SCION with MB-TCP or multipath TCP?
Right. So multipath TCP obviously gives you the possibility also to select between different paths. However, there you are typically limited to the paths that a multi-homing environment provides you. Yeah, if you are connected, for example, through Wi-Fi and at the same time through a fixed wired connection, or through a cellular connection together with a Wi-Fi connection, then with multipath TCP, you can benefit from this multi-homing environment. However, with SCION, you can really also select paths in the backbone network, different paths, and that gives you usually really a multitude of path opportunities. Yeah. Of course, you may use multipath TCP over that as well. Yeah, that's certainly possible, but it's kind of orthogonal. So it's multipath TCP is essentially a transport layer enabling multipath, whereas SCION provides multipath really at the network layer. I hope that answers the question.
We have also a second question that asks, how would you compare path awareness of SCION with segment routing?
Right. So SCION is essentially a specific type of segment routing. Without now going in further details about segment routing, but with the path segment concept that SCION has, it is a type of path of segment routing. Whereas in segment routing, I think there is typically even more flexibility. In SCION, one specific characteristic is that the paths that can be chosen by an end host are kind of given, yeah, following a beaconing process. I don't want to go in too much detail here now, because that would go beyond the scope of this talk. But you can find further details, for example, in the SCION book about this. Yeah. So the way these path segments are being constructed essentially follows a beaconing process, and that distinguishes it slightly from the more general segment routing approach. Now, after we've seen these benefits of SCION, I would like to summarize really the value proposition that SCION provides. So essentially, SCION is able to offer a highly secure and highly reliable communication infrastructure, but it does so and it does so, it achieves that at the level of private networks like leased lines, yeah. But it does so at the cost and flexibility really comparable to today's internet, yeah. And so this is essentially the great benefit. So you can use a public infrastructure like the internet in order to achieve those properties that traditional leased line provide, that potentially come at quite high costs. Now, I would like to mention two applications that can benefit from these SCION properties. One is Hercules, an application that we developed that aims at greatly improving performance of the transfer of large bulk files. So the way it does so is by leveraging really the path control characteristic of SCION and the multipathing possibility within SCION. It also does some further tweaks in congestion control issues that can be avoided, and also it takes into account especially high bandwidth delay path problems. It also avoids head-of-line blocking in TCP-based solutions, and does further improvements on congestion control and acknowledgement schemes. And finally, it also bypasses the operating system network stack using AFXDP, and that adds further improvements in terms of efficiency. And with this, we could demonstrate that Hercules is able to do file transfer over the SCION architecture at speeds exceeding 100 gigabits per second. Another application that benefits from SCION is lightning filter. It's essentially a firewall replacement that gives the possibility to do strong source authentication of every single data packet, something that firewalls really have difficulty to achieve, especially at very high speeds. And with SCION, we're able, with this lightning filter approach, to achieve that really at transmission rates over 100 gigabits per second, without the high costs that traditional IP firewalls would have in achieving this. Now,
David, we have
yes?
another question. Maybe
Okay.
maybe we could.
Yeah,
it was
if you could read
so.
it out.
SCION is a new internet with own fibers, or WDM or alike. What differentiate this from being an overlay or SD-WAN alike?
Right. So it is a kind of SD-WAN approach, if you want. It targets especially at the replacement of BGP. And so, yes, it can be considered an SD-WAN approach. It's not an overlay. I mean, it can be deployed as an overlay over BGP, but then it would suffer from obviously the BGP issues like link failures, convergence issues, and attacks against BGP. So that's why, especially in this initiative on deploying SCION natively as a production network on the GÉANT infrastructure, we really wanted to ensure that we stay entirely BGP free. And you mentioned there was another question, Marten, as well?
That was basically the question.
Okay, all right. So let me continue.
Yeah, thanks.
Now, given these properties, let me draw an example use case that I believe can be very beneficial for academic networks, universities that may want to make use of SCION. That is the high performance computing cluster use case. So as you know, today's research often relies on very large data volumes that need to be exchanged, for example, from a lab that produces a lot amount of data that is then analyzed by a lab somewhere in a distant location. Now, the point is that universities cannot always provide the required compute resources that is necessary, for example, to analyze this huge amount of data. And that's where high-performance compute cluster come into place, as they provide a cost-effective alternative in assisting those researchers at those universities with the necessary computing resources. Now, to assist that use case with SCION, HPCC and universities can basically be designed and operated as independent SCION ASs, where each of these ASs comes with its own lightning filter instance, as presented before, enabling really high volume data transfers using the Hercules application. Now, with lightning filter, traffic can pass through it instead of going through the regular firewalls, where it would potentially be throttled down because the firewall is simply not able to deal with this huge amount of data volumes. Yeah, and nevertheless, ASs remain control about this amount of traffic that they may potentially receive from other ASs. Now, if there are, for example, rate limits that need to be put in place, then the HPCC can enforce that using SCION and using lightning filter, while still guaranteeing a certain level of quality of service for specific hosts that need it. And also in case there are, for example, misbehaving hosts that may consume too much data at a certain point, with these solutions, we can effectively protect these services from those misbehaving hosts. All right, now with this use case example and the properties that SCION is able to provide, I hope by now that I have convinced you that it would at least be interesting to be part of that SCION architecture. And so you may ask yourself, so how can I get connected to it? Essentially, a SCION connection requires three components. First, you need a local network hardware and software that is able to speak SCION. Then you need a local access or a connection to a provider that is SCION enabled, for example, an NREN that has already deployed SCION, or GÉANT that does have the SCION deployment that I mentioned earlier. And thirdly, you may need a SCION transit if your desire is really to reach potentially any other network in the world using SCION. Now, the first point is to get local network hardware and software deployed in your own network. So the first ingredient that is needed here is a SCION border router. That's essentially the element down here in green. That's just simply a server that is necessary, whereas the entire rest of the infrastructure can be completely reused. So with SCION, the big benefit is that we don't need to replace the entire existing network infrastructure. We just need one additional off-the-shelf server in order to provide that. Now, NRENs themselves also need, of course, SCION border routers in order to become SCION enabled. At the very minimum, one SCION border router is sufficient, but potentially in order also to scale to potentially many customers, a more distributed deployment is necessary with SCION border routers located potentially at every POP of that particular NREN. Now, an additional element that is needed in order to also let non-SCION native applications use SCION is the so-called SCION IP gateway. the SCION IP gateway enables legacy applications that cannot be changed or shouldn't be changed to use the properties or some of the properties of SCION nevertheless. For example, the path failover properties or the resistance against the DDoS attack property, etc. Now, if you have here in this figure, we show 3 customers of an NREN, yeah, whereas 2 of them are SCION enabled, so they have SCION border routers deployed in their network, and the third one that is not yet SCION enabled. So with this SCION IP gateway, the SCION enabled networks A and B can basically speak SCION without noticing it. Yeah? So any connection that legacy applications will establish that originates, for example, from A and ends in B could automatically use SCION without those applications being changed at all. And if those applications, for example, originating in A would like to talk to an end host in C, then they would just simply fall back to the legacy IP protocol. And the same for communications that originates in B and would end up in C. And so this SCION IP gateway is really an element that ensures the backward compatibility with the legacy internet and doesn't require any update and any expertise by any user willing to make use of SCION. Now, at the very minimum, as I said, a machine, a Linux-based workstation is necessary in order to run both the local SCION router as well as potentially in order to provide SCION also to legacy application, the SCION IP gateway, that then provides full SCION connectivity to any host on the university or research institution network. Now, for this local network hardware and software, 2 options exist. Option 1A is to use a product from a company in Switzerland called Anapaya that offers such products, or B, to use simply the open source SCION software, which is also provided as packages for various operating systems, Ubuntu, for example, or other Debian flavors, Red Hat as well, etc. Now, both of these software versions run on the same type of commodity server hardware, and they also seamlessly integrate with the existing SCION network infrastructure. So Anapaya software instances are able to speak to open source software instances without any issues. Now, the difference between these 2 software versions is that the Anapaya software provides higher performance and also supports redundant deployments, for example, achieving active failover, and also reduces the management and operation effort. And of course, it also doesn't require the same amount of expertise needed in order to deploy the open source software instance yourself. Now, a second item that is necessary after having a SCION-enabled hardware and software in place is a local access or connection to a SCION-enabled provider, for example, an NREN that already speaks SCION. Now, this can come in 2 types of instances, either as a native connection or as an overlay connection. In between the NRENs and GÉANT, it's typically a native SCION connection because it's very easy with these GÉANT plus links that I mentioned earlier to connect an NREN and end these connections in one of the SCION instances within the GÉANT network. So that's basically what is necessary. So a SCION connection to the local network provider, an NREN that is able to terminate the SCION connection. Ideally, this comes as a SCION-only connection. That means a native connection, but it's also alternatively possible if that is not the case, or if that is not an option, to also use the existing IP access service and then just simply run SCION as an overlay over it. Of course, that comes at a certain loss of security and performance guarantees, but it may well be a first step in order to, for example, evaluate SCION and then decide for a native SCION connection later on. Now, this local access needs to be procured from any local SCION-enabled service provider, or a provider, if there is no such SCION-enabled service provider available locally, that at least offers some type of last-mile service to the closest SCION hub. In case your NREN doesn't provide SCION yet, or in case you don't have any nearby SCION hub available, just contact us and we can provide you support and explore any type of connection options to the next best SCION-enabled provider. Now, as I mentioned, NRENs have the possibility, if they are members of GÉANT, to just simply establish a GÉANT Plus circuit in order to connect to the existing SCION deployment within GÉANT. So here is a screenshot of how that works using the GÉANT platform, where it's really easy to request such a GÉANT Plus circuit. And you see here in this example, essentially the option to choose Geneva, the SCION router 1 in the Geneva hub, as an endpoint of that GÉANT Plus circuit. And so similarly, it's also possible to connect now to the Frankfurt SCION routers or to the Paris SCION routers. And it's actually recommendable to have at least 2 circuits to do 2 different POPs. For example, a switch does it right now. They have a connection to the Geneva POP as well as to the Paris POP, going over the backup connection that the switch has into the GÉANT infrastructure. Now, the third element that is necessary in order to also achieve global SCION connectivity is a SCION transit service. At this stage, GÉANT doesn't yet offer SCION transit because there is no connection yet to a SCION transit provider. This is something under discussion. NRENs may already do so. For example, Switch, I believe, has already transit that can be purchased. And so universities that do connect to NRENs that also do have the opportunity to connect to a SCION transit provider can then purchase that service additionally. And that gives them the possibility to connect to any SCION-enabled network worldwide. Right, so that's just summarizing what I've just said. So similar to regular internet service, transit that provides global internet connectivity, the SCION transit essentially offers global SCION connectivity. And of course, it's necessary for that the local NREN does offer such a SCION transit service. If not, also please contact us and we can explore what kind of options exist in order to provide SCION transit.
We have a short question.
Yes. Mm-hmm.
Who can be a SCION transit provider?
Right. Anapaya, for example, is also a SCION transit provider. I don't know if at this stage there also exist others, but yeah, Anapaya certainly is one option for that. So now, as I said earlier, in order to deploy SCION and get the SCION access, either you can just go ahead and install the open source SCION border router and also the open source SIG. Now, there is also a commercial offer from Anapaya, the Anapaya Edge product that comes with a SCION border router and the SCION IP gateway together. And the great news is that they offer this with an educational discount, especially targeted at academic networks like NRENs and associated universities and research institutes. A software subscription for research and education comes at a cost of 4,500 Swiss francs for a 1-year term, and that includes software maintenance services. Additionally, there is a one-time remote software rollout and installation fee that also provides access to training materials, etc., at an amount of 6,000 Swiss francs. Optionally, participants interested in deploying SCION can also purchase a managed service that comes with a zero-effort management package at the cost of 450 Swiss francs monthly, or alternatively a remote operational technical service and support at 1,600 Swiss francs per day. Now, this is really optional, and then would really not require any SCION expertise at all. It's an offer that then just takes care of everything and deploys and maintains SCION entirely by Anapaya. Now, to give you an idea on what costs we are looking at when we combine all the necessary ingredients, that means the local hardware and software piece, the local access, as well as the SCION transit, then we look as an indicative approximation with, for example, a typically 100 megabit per second local access at a total yearly cost that would typically amount to a maximum of 30,000 Swiss francs. Now, this information and further information can also be found in the SCION fact sheet that is available under this short URL shown here, and can also be accessed with that QR code. And we will make the slides available later on as well, and also the recording, of course. So you can download these additional information anytime you wish. Now, in the second part of this GÉANT Infoshare, we'll also show you how you can test SCION. So maybe you're interested in SCION, but you're not ready yet to immediately start deploying it using really a native SCION deployment with all the necessary ingredients, as I mentioned before, and you just want to explore SCION further and kind of understand what kind of properties and benefits it provides. And the best environment to achieve that is the SCIONLab infrastructure. I need to emphasize here that this is an overlay infrastructure, so it doesn't provide, of course, the same performance and reliability guarantees as the production SCION deployment. It's really a test network, but it's a quite large-scale deployment spanning various ASs across the world. And so it is perfectly fine as a test environment. And we did a lot of effort in making it really easy and fast to participate in SCIONLab with a low entry bar for interested users requiring only little technical expertise. It's very simple and automated in order to set up yourself a SCION AS. Such a SCION AS can be instantiated as a virtual machine in only a few clicks. Takes roughly 10 minutes. Yeah. And you have then the possibility to connect your SCION AS to multiple attachment points. This is supported with the OpenVPN, so that even if you are in a NATed environment, you can easily connect any of those attachment points and thereby participate in the global SCIONLab infrastructure. We provide, along with that, a number of Debian packages. We also have ARM packages, so in case you are interested to run this on a Raspberry Pi, for example, that's also possible. So later on, Marten will give a quick introduction into SCIONLab. This is going to be a little bit hands-on, so to give you really an easy access into this if you would like to explore this yourself and then really experience these SCION capabilities yourself with your own SCION AS in the SCIONLab infrastructure. Now, before we go into that, let me just start to summarize by looking at what's the next step. So now we have this GÉANT deployment, and we now have the window of opportunity for NRENs to join this infrastructure and also their associated universities and research institutes to connect here to a productive SCION deployment within the European academic research landscape. At the same time, we're also looking to connect other networks beyond Europe. For example, we are in close contact with GÉANT, that has also been an early adopter of SCION architecture and connecting that to the GÉANT infrastructure. That's something that has not happened yet, but that we are looking forward to establish soon. Additionally, we're also in contact with our colleagues in the US. We have a number of universities there as well that are interested in participating in SCION, for example, at Princeton, University of Virginia, and furthers. And we also would like to get them connected, for example, over an infrastructure called Bridges that is supported by the NSF. I will have a slide on that in a second. That will then also give us the possibility, for example, to connect to the internet too. That will then give us connection opportunities to a whole lot of additional universities and research institutes in the US. And that's exactly this plan here in respect to NSF Bridges, an infrastructure that is funded by the National Science Foundation and offers two 100 gig links across the Atlantic, one between Washington and Paris and another one between New York and Amsterdam. And our idea is to establish cross connections to this infrastructure, one in Paris from our SCION node in Paris, and another one to Amsterdam, potentially with the help of SURF and the University of Amsterdam. We are currently in contact with them to then be able to connect our existing GÉANT SCION deployment using Bridges infrastructure with the internet too and the universities there in the US. All right, so if you're interested, and I hope I have catched the interest of some of you, you will find further details about SCION on the SCION website, scion-architecture.net. There you can find the recent SCION book that is shown here, the complete guide to SCION. Also find papers, videos, tutorials. Then, as mentioned, the SCIONLab infrastructure that's available under scionlab.org. Then recently, we have established the SCION Association that is dealing, for example, with standardization and certification of SCION services that is available at scion.org. Then Anapaya was mentioned, that is mainly dealing with the commercialization of SCION and offering SCION products. And last but not least, also the source code that is entirely available under GitHub under the URL indicated here. So with this, I'm done with the first part. And if there are any questions, any additional questions, I would be very happy to answer them before we go to the second part. Martin, if you could maybe read out the question in case there are any further questions.
Yeah, from the chat, we have the question if the audience can get the slides.
Yes, absolutely. We'll make them available on the GÉANT Infoshare website, and we'll also make the recording of this session available there.
That's it, at least from the chat.
If there are no further questions, I would like to hand over to Marten Gartner, a researcher in my team at the Otto von Guericke University in Magdeburg. And Marten will now continue with a quick demonstration of the SCIONLab infrastructure that anyone can use essentially to test SCION as an overlay infrastructure. So Marten, I will stop sharing my slides so that you can share yours.
Yeah, sure. Thank you for handing over. Just a second. So let me share my window. I hope you can see it all.
Yes, we can see that.
Okay, and I hope you can also hear me.
Yes.
Great. Then let's get started. Thanks for introducing me, David. As Professor Hausheer said, this is about a short hands-on to SCIONLab. So basically how to create your own AS, how to connect to the network, and finally how to set up and configure a SCION IP gateway instance. Yeah, and I have a recording here that I want to play and just explain the required steps. So we start here on the SCIONLab.org website, which is basically a mix of a documentation for SCION and a coordination application that allows us to easily connect the SCIONLab. Yeah, here at the right, we can see the current topology of SCIONLab. This was already presented in the talk. And we can just start by clicking the Join SCIONLab button. After this, we get to a registration form, just basically just email address, names, and passwords. So we have a fast forward here. So after registration, you will get an invite link to your email address. You can just click onto, and then you have verified that it's your email address. And then you can log in to SCIONLab.org via email address and password. And the homepage that we see when we log in into SCIONLab.org is basically the overview of our own ASs. So each user can create up to 5 user ASs with his or her account. And yeah, that's what we're going to do. So we click create a new SCION AS. So here we can see the SCION login, the SCION AS creation form. It starts with a label, which is basically for ourselves to identify. We can give our AS a name, maybe the purpose of the AS. And the next thing that we can select is the installation type. We will choose the simplest approach to run SCION in a Vagrant virtual machine. This will basically give us a Vagrant file that we can just spin up, and then with VirtualBox and Vagrant installed, it will allow us to set up a virtual machine in a few minutes with our fully configured SCION AS. This assumes that we have Vagrant and VirtualBox installed. Here are otherwise links that help installing Vagrant and VirtualBox on on all kind of operating systems. The other two options are SCION installation from packages, which is basically we can use the Debian or ARM package, or there's also built for Arch Linux, just to install it. And for developers who want to get in touch with the internals and the code, it can be also installed from sources. But as we said, we want to use the simple vagrant virtual machine approach. So we keep this selection and we skip this, make this AS as publicly available attachment point box, because we want to have only a simple user AS. And now we can select our provider links. As Professor Hausheer said, we have a set of pre-configured attachment points, which are basically our entry doors to SCIONLab. So 5 of them are running on our infrastructure nodes and are distributed over the world. So we have 1 in North America, 2 in Switzerland, 1 in Magdeburg, and 1 in Korea. So it's basically recommended to connect to the one that is closest to ourselves. So we select the one in Magdeburg here. And as suggested in the talk before, it's a good idea to toggle this use VPN button, because it will create a VPN tunnel from our virtual machine to the attachment point that we select here. So this avoids any problems with firewalls or nothing or whatever. And if we don't want to use VPN in this configuration here, we would need some public available IP address and a public port that is accessible from outside. But with this use VPN configuration, we can skip a part of the public IP. We may also change this port here, but it's just recommended to keep it as default. And after clicking save, we can now download our configuration. Clicking this button will basically give us an archive that we want to extract that contains our vagrant file and a README. So it's can simply be extracted with any kind of tool like here 7-zip. And yeah, this vagrant file basically then can be used to spin up our virtual machine. The command to use this is just vagrant up. So this may take a few minutes. So we have fast forward here. Yeah, so this is how it looks like. It's creating the virtual machine. It's setting up all SCION services. And then with vagrant SSH, we can just SSH into our virtual machine. So here we have our own SCIONLab AS in a virtual machine. It's running Ubuntu 18.04. This is basically our default for this. We could also upgrade it. So SCION is not restricted to this specific Ubuntu version. Yeah, so let's have a look at our virtual machine. We have basically 2 important interfaces. One is the EPN0S3, which is basically the bridge interface to the host. Yeah, and the TAN0 interface, which is the VPN tunnel that our SCIONLab configuration creates in the virtual machine. And over this TAN0, we can just connect to the attachment point. Yeah, so in our VM, all important SCION services are installed as systemd services. So with this list dependencies command, we can have a look if all of them are running properly. And they are grouped into this SCIONLab.target group. So we can inspect if everything is fine here. We have a few services that run on AS level. So of course, the border router service. Here we have also pre-installed a Colibri service, which can be used for bandwidth reservation. And the control service that is basically responsible for fetching path segments and interacting with the control plane PKI. And then we have 2 services that are basically running on each SCION-enabled host. SCION daemon, which is a caching layer between the host and the control service, and the SCION dispatcher, which is basically responsible for handling all incoming and outgoing SCION packets. So all of our SCION configuration is, yeah, so with journal control, we can also just inspect the logs of all these services. So they are running in info mode, and after startup phase, they usually don't log that much, except if something goes wrong, then we can have a look here to see any errors or warnings. and so on. So this could also be changed to debug mode then to have more information. Yeah, and the core SCION installation we can find in the /etc/SCION folder. So here we have a list of configuration files for the border router, for the control service and dispatcher SCIOND. Also SCION cryptographic elements like certificates, keys, and some things like this. And also two JSON files that are quite important. So the first one is the SCIONLab config JSON, which basically contains your host key and your host secret. With these two information, you can talk to SCIONLab.org and can fetch your personal configuration for this AS. So this can be used to update your configuration, or if you accidentally break something, then you can just get the latest version from the SCIONLab.org, and then you're ready again. And also the topology.json, which describes the local AS topology, including the services. We can just simply cut the file and see what its contents are. So the first important sections are the border routers. They are configured here as JSON objects and basically configure interfaces to remote border routers. So in our case, we have an interface to the parent, which is the Magdeburg attachment point with this ISD and AS number. And it's configured using an underlay option, which basically has our local public IP address and the remote public IP address, which fits our VPN tunnel that we created. And also the border router has an internal address, which is used by all kind of SCION applications that run in our own SCION AS that want to talk to remote SCION ASs. So every local application sends its packet to this internal interface. Since our VM is basically just one host, it's totally okay that this is the loopback address. And then we have another configurations for the Colibri service, control service, and also for discovery service. Then we can find our own ISD and AS number here, and also configuration for SCION IP gateways. We will skip this now and have a look at this later. Yeah, and after having a look at the configuration, we'll now see a few SCION applications and commands that are pretty useful. The first one is SCION show path, which basically prints us all available paths to a specific destination. Here to this ISDAS, it's basically limited per default to display 10 paths. So these are not all available paths. And as we see here, it in the first call just fails. This is because the control plane needs a bit of time until it's fully up and has all path segment fetched. And then we get this kind of output here for paths. So it's showing us the number of paths for a specific number of hops. Like these 4 paths have 6 hops, and each of these hops is basically an AS on the path. So we see the ISD and the AS number here. SCION show path does also alive checks for these paths. So as you can see here, they are all green and alive. And they're showing us the local IP that is used to perform this command. So with multiple interfaces on a machine, these local IP can be important to show specific paths. Yeah, the next interesting command is for the SCION ping. We call it basically by ISD-AS as an argument and the AS internal IP address from the node. And it's basically the SCION equivalent to the usual ping command. So we are sending SCMP packages, the SCION control message packages, basically the ICMP equivalent. And the output looks quite similar to normal ping. It displays the amount of bytes which are transferred, the sequence number, and also the time until the response arrives from this remote endpoint. And it also displays the path that was used. This is initially the first one that was found. And this command also supports an additional flag called -I, which is the interactive mode. So this displays us all path options, which are around 80 in our case, and we can choose one of these paths to perform our SCION ping. This can be really helpful just to try out a few paths. And here we can see if we take a longer path, then we see that this time until the response arrives is also quite longer. Yeah, this was the SCION ping command. Now our SCIONLab team provides a list of other sample applications, which is called SCION apps. This can be just installed as a Debian package. And yeah, the first one is this bandwidth test client, which basically takes as an input a remote address and some configuration and duration, the number of packets, and the packet size, and then it performs a test about the bandwidth that can be achieved and detects the packet loss. So in this case, we use one of the pre-configured test servers. We could also run our own, but for starting, it's easy just to use one of the existing ones. And then it does bandwidth testing in both directions from client to server and back. And another pretty neat tool is the SCION web app that we want to have a look at. This can be just started as a systemd service. And then we can go back to our host and open it on localhost with port 8000. So this port is configured to be tunneled to the virtual machine. And the starting page that we see is the health check of our AS. So we can have a look here, and it's checking the basic configuration and if everything is working as expected. This can be helpful if any issues occur to start debugging. The next page that we want to have a look at is the apps section. So here we have basically a UI that wraps some sample applications like the bandwidth tester, the ping, or even trace route. So we can configure the source here, which is basically our AS, and the destination. And yeah, just run a few SCION commands here, the bandwidth tester, for example. And we can have a look at all of the available paths and see them visualized here as a kind of graph. So each of these bubbles is an own AS, and the colors are grouped by ISD numbers. Yeah, it's also the SCION ping command that can be started over this web application. And the SCION trace route, which is basically the SCION equivalent to the normal trace route. And it will just ping or each of the ASs that is on the path and display us the time that the packet requires until it arrives back. Yeah, and with this visualization here, we can also click on paths to highlight them here in the topology graph. So we can see which hops are traversed by selecting a particular path. So we also see the number of hops. And what we could also do is to print the actual AS numbers or also the AS names. This is very helpful to play around with specific path alternatives and see how these paths look like. And another pretty cool feature is to see where our packets traverse the global network. This can be done with this map integration. So we have geolocations assigned to specific ISDs, and we can see the actual paths over the map that these packets then will use. And what we can see here is that with short paths, we may achieve good latencies and can see that our data will surely stay in Europe, for example. And for longer paths, we could also see that packets may traverse 2 times the Atlantic, for example. So this helps us to visualize what exactly we have for alternatives and what also improvements we can get by seeing, okay, with using these paths, we can ensure our data is in Europe and we avoid any cross-Atlantic links, for example. So this is pretty cool for playing around and visualizing the paths. Yeah, so before we hand over to the SCION IP gateway configurations, are there any questions so far?
Not in the chat, and
okay, great.
so you may just continue.
Yeah, then I will come to the last part. So this is the configuration of our SCION IP gateway. We already had some information about the purpose of the SCION IP gateway. So just to provide easy interconnections of legacy IP gateway IP networks over SCION. And this is exactly what we are going to do here. We have basically two SCION ASs, each in a dedicated VM. And we want to connect local networks in these VMs via SCIONLab. So the first step is following this guide here to install the SCION IP gateway. This is available as a Debian package. The next step would be to configure this in our topology. But as we already saw, per default, these configurations are set. So we can skip this step here. And yeah, following the documentation, there are basically SIG JSON files in our SCION configuration folder. And what we need to do here is just replace these placeholders here. So the documentation provides us some sample networks that we may use. And this is what we are doing here. So we see the remote SIG AS and the remote SIG IPNet can just replace with the AS number of this AS here and with its local network that we're going to use. And the same we are doing in our second virtual machine. Yep. And then, of course, we need some network interfaces that exactly match or that are part of these two networks. So since we are in a single virtual machine, we can follow this fake local IP address and just basically add this IP address to the loopback device so that we have one interface that is available over this IP address. And before starting the SIG, the basic thing that we need to configure is the local source IP address in a file called sig.toml. So again, following just this documentation. And then we are ready to start our SIG via just starting as a systemd service. And then we can use the status page the SIG provides to check if it's working properly. So what we can see here is the SIG routing table and also the paths that are used. So we have this network here, the .12 subnet. It's active, and you see that it has one session with using this path here over the Magdeburg attachment point and a configured next hop. And basically on the other side, we see its counterpart. So here it's routing to the .11 subnet and basically has the reverse path configured. We could also check this using IP route in the kernel. So it's just adding these two as kernel IP routes. And then after we've configured our SIG, then we are able to ping the interfaces of the remote AS machines over SCIONLab. We can see here they're basically running on the same host, and since this the packets are traversing the Magdeburg attachment point, we can see that it took a bit over 100 milliseconds. Yeah, but it's now serving for every kind of legacy IP application that can be used to just talk to these two hosts, and everything will be encapsulated through the SCION IP gateway. Yeah, that's basically it from my side with the hands-on. So if you have any questions or comments, please feel free to ask or to comment on this. And yeah, thanks a lot for all of your attention.
Thanks, Martin. Yes, there is a question from Carsten Pettersson. He's asking, so if you hook up in the SCION network and offer this to NRENs, how will each application be selected for SCION network and other for normal traffic? So meaning like some are SCION native and others may be just legacy internet applications. So will all applications need to have some kind of SCION daemon installed? By all application, he means like of any servers or clients in the network.
Yeah, so basically, if you have any IP application that wants to reach the network of a remote AS, then this application will be SCION enabled through the SIG if the SIG has a specific route to do so. So this will just kind of forward all traffic to the remote AS. The other way to connect specific applications would be to install SCION host services on the specific host, so the daemon and the dispatcher. And then we provide libraries just to make a specific application SCION enabled. Then this application will just talk SCION without any SIG in between. So these are the two possibilities. But in the SIG example, basically all applications that send packets to a route that is in the routing table of the SIG will then be SCION enabled.
So we have around 5 minutes left now. We are coming to an end of this Infoshare. So I would like to ask again in the round if there are any questions. You may ask them either in the chat or you may also use your microphone if you prefer. All right, that does currently not seem to be the case. Many questions have already been asked during the two.
Sorry.
Yes, there is one more.
I
yes.
have one question, Carsten from Nordnet. Yeah, for the banks you referred to earlier,
yes.
Which kind of applications are they using the SCION network for? Do you know?
That's a good question. So essentially, the new banking network, the bank interchange network, is using SCION. I don't know. Maybe Daniel Bertolo, you are on the call as well because you're involved there. Maybe you can say more about that. Because
yes, I can. The banks actually use it for the interbank clearing, so to exchange money amongst each other. So this has been done using an MPLS network in the past, like a hub and spoke topology with our payment processing provider in Switzerland. And now they switch to a SCION network for the interbank clearing.
Okay, that makes sense. Yeah, good. Thank you.
Thank you, Daniel. Are there any further questions? So there is not a question, but a remark that, well, basically, thanks for putting this up. Yeah, it has been our pleasure to do this Infoshare, and I hope it gave you some insight into SCION and also specifically the SCION productive deployment within GÉANT and the associated NRENs and universities. We hope we have been able to convince at least some of you that you remain interested and perhaps will investigate further, potentially starting with SCIONLab to really get more familiar with the SCION capabilities and test these features with applications that are provided as part of SCIONLab. And then if you, of course, are still interested, would be very happy to also help you in exploring the different options that we have presented, either by using the open source software version or an unbiased version, and also by the connection opportunities. So this is a network that is expanded right now. So it's really the window of opportunity to join and to explore all the features that SCION provides. And so if it raised any further questions that you may also want to discuss with us bilaterally, or if you would like to explore what kind of opportunities you have to benefit from SCION, please come talk to us, contact us, and we can also make a follow-up Zoom call, for example, to speak about those questions that you may have or that may arise after this info share. Yes, the slides will be made available as soon as possible. We'll send them to the GÉANT folks right now so that they can make it available as part of the event website. And also the recording of this session will be made available. So that brings us to the end. Thank you everyone for participating and for your interest, and thanks for all your questions. And yeah, wishing you all a very nice rest of the afternoon, and wishing you all a very nice rest of the week. Thank you very much.